Hello! In this video we're going to install Greyhole on a Raspberry Pi. This video is actually part of a series of posts I've written about building a network-attached storage solution with data redundancy. Data redundancy means that each file is saved multiple times to protect against hard drive failures. Those posts also contain a lot of information about many of the topics that matter when building a NAS. For example, network connections, the properties of hard drives and solid-state drives, power consumption, smart and much more. I'll put a link to the posts in the description of this video. I think it's a really interesting read. I'd love to get some feedback. So, for this NAS, I'm using a Raspberry Pi 4B as a server and a few HDDs to store data. The data on the server is shared via Samba shares, so Windows, Mac and Linux systems can mount them. Data redundancy is achieved with a piece of software called Greyhole. Greyhole monitors what happens on a Samba share and then moves and duplicates the files from the Samba share to a set of storage drives. You can choose how many file copies should be saved, and the files that were originally saved on the Samba share are replaced with symbolic links to the new locations of the files. So when you want to read a file on the Samba share, you're actually redirected to one of the storage drives. So that was a very short overview of this NAS. The posts are linked to below go into much more detail about why I chose this specific setup and about different aspects of using Greyhole. So let's start with the installation. Let's start by installing Raspberry Pi OS on an SD card. I'll use the Raspberry Pi Imager, which I've installed on the Arch Linux system. You could also do the installation via the command line, but it's just easier with the Imager. First, let's select the operating system we're going to use. I'll just use the latest version of Raspberry Pi OS available to me. Whichever version you choose, make sure that it's a 64-bit version. Greyhole doesn't work with 32-bit versions. As installation target, I'll pick the SD card I've just connected. Before we start writing the image, we can already configure some settings for Raspberry Pi OS. I set the host name to rpi-nas and activate public key authentication. The username will be NAS user. If only one user will be using the NAS, then you can also just use their username. I won't set up Wi-Fi because Ethernet is much faster. Now we can start writing the image. If you get an error about not being able to access the disk, then you may have to add your user to the disk group. So after some time, writing the image will have finished. We can remove the SD card from the computer, plug it into the Raspberry Pi and boot it up. The first time you boot the Raspberry Pi will be a bit slow. After it booted, I connected my keyboard and mouse and I changed the screen resolution so it's easier to see what we're doing. First, we're going to update and upgrade the system. We'll install a firewall and allow all local traffic and block everything else. You can be more or less strict depending on your situation. Just make sure that Samba and SSH can get through the firewall. Now you could set a static IP address for your Raspberry Pi. A static IP address means that the address won't change when you reconnect to the network, which will make it easier to connect to the NAS. Some networks only use static addresses, but most home networks allocate them dynamically with DHCP. I've already reserved an IP address for the Raspberry Pi on my router, so I won't do it here. Next, we'll install two programs that I normally use. The first is Vim for editing files, and the second is Ranger, which is a file manager. We'll also add an alias for Ranger, so it's faster to start it. I do have a fan on my Pi, so we'll set that up with raspi-config. and then we reboot. We've done the basic setup now. Let's check if we can connect. So back on the main system, first we'll add the Raspberry Pi to the SSH config file, so we don't have to type the IP address every time we want to SSH into it. I've already done that here. Then we try to connect. Since this is the first time we're connecting to this device, we have to confirm it here. The connection works, so let's go back to the Raspberry Pi and install Greyhole. The installation is quite easy. We just have to type the command shown on the screen. It will take a while to complete. Once the installation is finished, we can prepare the drives on which we'll save our data. First, I connect the 4 drives to the Raspberry Pi. They already have a file system, so they are auto-mounted to the media folder. We unmount them now because we'll create dedicated mount points for them later. I will partition and format one of the drives now to illustrate an important point in the setup. We'll be using fdisk. P prints the current partition table. With D we can delete existing partitions. With N we create a new partition. We'll just use the default settings, which results in one partition covering the entire drive. With W we can save and exit. Now we have to format the drive. I'll be using ext4, so we'll type sudo makefilesystem.ext4 followed by the path to the drive. Let's create a temporary folder and mount the newly formatted drive. If we now look at the ownership and permissions, we see that the drive is owned by root. This is the first really important point. For the Greyhole setup to work, every user needs to have full access to the drives. One way of achieving this is by changing the ownership of the drives to NAS user and to all users. Here I'm just doing that for illustration. Later we'll update the ownership of all drives. In general, if you ever have a problem with accessing data on your drives, then it's probably related to issues with file and folder permissions. Okay, so let's create mount points for the drives. I use a folder called NAS mounts to hold the mount points, but you can really put them anywhere. Let's call the actual mount points drive 0, drive 1, drive 2 and drive 3. We want the drives to be mounted automatically, so let's open fstab and add a line for each of the drives. We can find the UUIDs by running ls-l dev drive by UUID. So let's copy the UUIDs to the file system table. We'll also specify the mount point, file system and mount options. I've added the nofail option, so the system boots even if the drives are not connected. The last 2 values determine that a hardware check should be done on boot. After closing fstab, we have to let the system know that it changed. And finally, we can use findMount to check if the updated file system table is okay. Now we can auto-mount the drives to their new mount points. Before we do that, let's look at the file ownerships and permissions of the mount points. Right now, the folders are owned by root. So let's auto-mount the drives to their new mount points and look at the permissions again. For one of our drives, our user is now the owner, which is what we set earlier in the change own commands. So Greyhole will save our data into specific folders that we can choose. We'll create a folder GH on each of the drives. We also need a folder to hold the Samba shares. The Greyhole wiki recommends using the largest drives for your Samba shares, but you can really put them anywhere. There just needs to be enough available space, so all the data that you copy onto the share can be saved until it's processed by Greyhole. Since all users should have access to these folders, we now change the ownership of the mount points. The -R option of change own means that all subfolders, so the GH and the share folders, are also updated. So we've prepared our drives, now we can set up Greyhole. There is a web interface which we can start with the command you can see on the screen, and we can access it in our browser at localhost:8012/install. that takes us to the setup wizard. The documents linked to here are definitely worth reading. On the next page, we can create Samba users for everybody we want to have access to the NAS. For this demo, I'm just going to create 2 users, one for NAS user and one for my own user. Now we can add Samba shares for each of the folders we want to access on the network. In this video, I only create one share to which everybody has access, but there is a blog post that goes into more detail about the configuration options of Samba shares. Double check that the path to the share is correct. To change it, you would have to update Samba's configuration file. Finally, we have to set wide links to yes and Unix extensions to no. Note, wide links here is a system-wide setting, whereas before, under additional options, it was a share-specific setting. The third step shows an overview over the shares. In the column on the right, we can set the number of copies we want to save of each file in a share. So 2 copies would mean 1 backup. But right now, we only have the option to use 1 copy. And that's because we haven't yet added any drives. So we'll come back to this setting later. For this demo, I won't change any of the settings of the SQL database. Let's add the drives now. Again, make sure to type the path here correctly. You notice that the drive I've added doesn't show up. If that happens, don't try to add it a second time. Greyhole has added it, it just doesn't show it here. If you add it a second time, then you'll have to remove the duplicate entry from Greyhole's configuration file. Otherwise, your Greyhole system won't start. We won't change any of the settings here, but do have a look at them. There are some interesting options. So we finished the wizard. If we look at the storage pool, we can see that all 4 drives have been added. So if we go to the page we couldn't finish earlier, then we see that we can save up to 4 copies of a file. If you make a change here, then you'll have to restart the Greyhole daemon. And that's the setup completed. If we look at the disks, we'll see that for each of the Samba shares we've configured, a new folder has been created inside shares. The owner of these folders is root, but everybody has access. So far, no subfolders have been created in the GH folders. That will happen when data is added to the NAS. I think that's quite enough for one video, but there are a few more things we should discuss. So have a look at the blog post I linked to below for more information. Thanks for watching.